Let's go ahead and look at this. What we are going to do is kind of understand. We did graphing, especially linear graphing, a long time ago. In your first, probably you started graphing in like September, October. We're not really going to graph, but we're going to understand how this works. So I'm going to teach you how, basically I'm going to teach you how we get this. And we're going to focus today not on getting this. We're going to focus on what this means. Okay? And so I want you to do this first problem in your notes, not for homework, but in your notes. And we're going to write some things with your notes so you have some information. The first thing I want you to do is I want you to hit the data button again. Because basically this is what we're doing. This chapter is data displays and what they mean. And we're about done with it. And then we'll move on to doing various statistical things. Okay. So I look at this table right here. And I see how many columns? 1, 2, right? So I'm going to type this into my calculator just like we've been doing. Except for I'm going to type the first column and the first column and the second column and the second column. So go and do that and see how that works. Okay. I think I got mine right where I see how I typed in both columns. I typed the first column all the way through, and then I typed the second column all the way through. So go ahead and do that, and I'll show you what to do next. Okay. After you put in your thing, we're going to hit second, stats, just like we've been doing. Before we hit one variable, how many variables do you think this one has? Well, 2 columns means 2 variables. So I'm going to go to 2 variable stats and hit enter. This is fine, just hit enter, enter. You basically want X to be first and Y to be second, and calculate. Okay, so we need some stuff and things from here. We could come up with the mean, but that's not really what we need. What we need is, if I can find it, there's a lot of information that we are not going to go over. What we need is go all the way down to A. Okay, so I'm going to write that down. A equals, I'm going to round because we can round, it's fine. 0.0814. And then we need B. Here, I'll just round this, let me round B to 37.2. Okay, so we remember this, right? Y equals mx plus b. Okay, well, guess what? This B is this B. It's the y-intercept. In statistics, unlike algebra, statistics doesn't have y equals mx plus b. In statistics, they didn't like the fact that there's an m here because the m actually doesn't have any meaning. Just some French guy decided that m would look good there, and so he put it there. In statistics, they write the same thing as y equals ax plus b. The thought process is A should go first and B should go second. But no matter what, M or A, doesn't matter what you use, that's going to equal the slope. So in this case, this A is the slope. Okay. So what they did is they took this data that this did, and again, we could do this by hand. It's just very painful, and that's not the purpose of what we're doing. Once we get to this level of graphing, we're going to go ahead and let our technology come up with this, so we don't have to do that by hand. But for today, it's done for you. Did we get the same thing as they wrote up here? Where this is the slope, the A, and this is the y-intercept, the B. Okay. And so they did a little graph here. Okay. So notice how the data points aren't exactly on the line. Because real life is messy, so it's not exactly on the line. What we have calculated is the line of best fit, where basically the points are very close to this line, right? And when we talked about standard deviation or deviation, when the points are very close to the line, the deviation is very low. As they spread out, and we'll get into how that works and looks in a little bit. When you have an increased deviation, that means the line is less accurate. So we're going to use this line to do several different things. The first thing we're going to understand is, what does the slope represent? Okay, so let's look at slope. Slope means something. We know slope is what? Rise over what? Run. Rise over run. Or y over x. But we need to write it in words. So the most simple way I can write this is going to be y per x. Okay? Per is a word that basically means to divide. But we don't, you don't go to the gas station and go, how much does it cost? How many gallons divided by miles is it going to cost me to get gas? You don't say that. You say miles per gallon, right? So, but per actually means divide. So that means divide. So let's look at our thing, and I'm going to show you how to do our thing here. Okay, what does the slope of the line represent? Well, instead of writing x and y, I'm going to write these words. And I might not write cost. I see this little dollar sign. So the cost is in dollars, so I might write dollars. So this would be A. Dollars per what? What's on the bottom? What's on the x-axis? Dollars per mile. So the slope represents the cost in dollars per mile. That's what it represents. And so we're going to make this a little we're going to make this a little prettier than just dollars per mile. What do we think is going to happen to the cost? Is the cost going to go up the more miles we drive? So maybe we might write something like, in a sentence, because that's ugly, we might say the slope represents the added cost per mile. Maybe that sounds better. We could write the added dollars per mile, but maybe the slope represents the added cost per mile, the added dollars per mile. Something like that. That's what we're doing. We're adding, the further we go, the more we got. Something like that. I'm trying to keep the sentence simple so you don't struggle with the English part, but you get the math part. Okay, that's what that is. Okay, let's look at the next question. What does the y-intercept represent? Well, this is the y-intercept right here. Okay, and so here's what I'm going to write for you. So we have this information about slope so the y-intercept is always going to be the start. That's where our graph is going to start. Okay? And when I say always, it's not always forever for every kind of graph that you have. mainly for the linear graphs we're working with. So each graph is going to be a little different, but we're worried about these linear graphs right now. So it's mainly going to be a start. Okay, and so look at here. This is basically where my graph starts, isn't it? So is this starting at 0? So it's not. So even before I start, what am I doing even? I'm just driving someplace? I'm flying someplace, right? So even before I start flying, there's a cost. Why is there a cost before I even take off? In an airplane. Well, shouldn't it be free to see an airplane sitting on the ground? So probably someone had to buy the airplane, right? And if you didn't buy it, you'd have like a loan, so you'd have to pay a monthly payment. Okay. It would be nice to own an airplane. And probably you got to hire a pilot, right? And does the pilot get paid if he's just sitting on the ground or flying? He's probably going to get paid just sitting on the ground because he's not going to show up if you're not going to pay him, right? So this probably represents the starting cost. Okay, so that's what those represent. And so now we're going to move on to the math part. And you don't need a fancy calculator for the math part. Okay, what we are going to do here, and this is probably the most important thing that I could teach it, especially in this COVID year, is this term. I'm going to spell it right. So let's write the two most important terms probably that we have this year. Let me make sure I spell this one correctly. Okay. And of course, that's not good. Let me spell it right. So extrapolation and interpolation. These two techniques are what we do is we take data and we basically predict where the data is going. So the extrapolation, it says extra. This is either beyond the data set. Okay, basically what that means, to be beyond the data set, that means you're kind of predicting the future or you're predicting what might have happened in the past. So it's what's not included on the graph. In this one, enter is going to be inside the graph. So that's inside the data. Okay. And so this is what they did with the COVID stuff. They did this right here. Okay. How did they know when something was going to get bad? Did they know for sure that something was going to get bad? Or did they look at the data and predict? Okay, and that's what they did inside the data. Okay, an example of this, interpolation. An example of this is like, you count how many kids were at school on Monday, count how many kids at school on Tuesday. I wasn't here Wednesday, count how many kids at school on Thursday, how many kids on school on Friday. So I can take those numbers and guess that probably they're about the same number here on Wednesday. So that's like in the data set. So let's look at our set here. And yes, I realize this takes a little bit longer to explain. That's why I'm working with you. Okay, so using this model, we're going to extrapolate. What would be the cost of the flight that travels 800 miles? Round your answer to the nearest dollar. So now we're finally doing math. We're going to use this formula. We're going to use this formula to put this in. Where do we think we're going to substitute that number into this formula? $800 miles. Is 800 miles going to be an X or a Y? Is miles an X or miles a Y? Right? So this is how you extrapolate or predict what would the cost of the flight that travels 800 miles. I do this. Y equals 0.0814 800. And yes, you're going to be required to write this down. But there's no steps. Now all we have to do is put that in the calculator, right? Not in a special fancy way. You just type it in. 0.0. I want just regular. 0.0814 times 800 plus 37.2. So this would cost this is a cheap flight. Maybe this is per ticket. This would cost Is that what everybody else is getting? Yeah. And they say round your answer to the nearest dollar, so I guess I'm supposed to write this instead. Is that what I'm supposed to write instead? So $102. That would be the cost of that flight. All right, let's look at D. According to the model, how much would a 3,025-mile flight cost? Round your answer to the nearest dollar. I guess this one, 800, is in my data set, so it's not an extrapolation. It's interpolation. So this one is definitely outside my graph, right? My graph stops at about 2,000. So this one's definitely outside my graph. So we're going to do the same thing with this one, but we're going to use a different number. Put it in the calculator and tell me what you get. How much money? This flight's going to cost what? Okay, and I'm supposed to round again to the nearest dollar, so I'm going to do that. So $283 is what that flight's going to cost, right? And don't worry, I know we're doing a long time teaching. That means if I teach a long time, what does that mean? No work. Less work. Because I'm kind of just doing your work with you right now, right? Because this is a little harder than your normal work because you're answering questions. All right. E. What distance corresponds to a cost of $80? Okay, this is different. $80. Where would dollars go? We were doing distance, now we have dollars, right? So dollars is going to be for Y, right? So this is how you set up E. $80 equals, and this is where the Algebra 1 comes in. That's how you set that up. And this is where the Algebra 1 comes in. I'm supposed to subtract 37.2. I don't know why I drew that line. And it's not getting any harder than this. So this is as hard as it gets. There's not going to be a next level. It is a little bit annoying because we have this big decimal. So what do I do now? I just divide both sides by okay. So it looks to me like I got 525 miles. Is that right? I don't know if it's right. What do we think? Did you get 525? Let's look at the graph, because I don't think it's right. Let's look at the graph. Okay, 525 miles. So 525 would be, that's like 500. So 525 might be like here. Right? So I'm gonna move this up, and let's see what the cost would be. That's 75. That's about 80, isn't it? On the graph. So that's a reasonable prediction that 525 is going to cost about 80, right? You see how that kind of works with the graph? That's what we're doing. All right. And again, I'm kind of working this with you. And so we're going to work on the next problem. This is where your homework is going to start. So you're going to need a separate sheet of paper because we're going to start your homework, even though I'm going to help you go with it. Because we're going to answer the same questions. This is going to be a different subject. That's what's fun about it. Statistics works in science. It works in all kinds of different things. Economics. This was probably economics because we're dealing with cost and distance. This looks like a science thing. We're dealing with air pressure and wind speed. So it looks like the hurricane hunters took the following measurements from a hurricane over several days as it developed. So basically these people are studying a hurricane. Now they did all the math for you because I really wanted to give you this so we can interpret it. This is the formula we're going to use. This formula equals this line. Notice that the slope is negative. Okay? That's why the line is going down. Okay? And remember, this is independent and this is dependent. Okay. Because y depends on x. So I'm going to write x, I'm going to write y. What does the slope of the line represent? So write it down and see if you can get it right. And I'll do it kind of with you. So this is A. I guess we need to put 2. And I'm betting you probably have figured out that we're probably not going to finish this packet today. Okay, what does the slope of the line represent? If you have no clue where to start, just write rise over run, but instead write the words. Maybe air pressure. Well, that's not the rise. That's the run. I got to write rise over run. So wind speed over air pressure. Wind speed per air pressure doesn't make sense to me. Okay? I wish it did, but it doesn't make sense. I've never heard anybody say that in a real thing. So instead of per, I might use the word change. So maybe this represents the change of what? The change, what's changing? Well, I need to write this first word first. The change of wind speed. That's what's changing. The change of wind speed, what? Maybe, I don't know, maybe we want to do the change of wind speed for based on the increase of air pressure. And I know this is hard to come up with. There's so many ways to write it because right now we're doing English, right? And so how many ways is there to write a sentence? So the change of wind speed based on the increase of air pressure. And it could be, instead of the change, we could say the lowering of the wind speed based on the increase of air pressure. Something, when I'm grading something like this, I'm looking for this. Did I leave out a letter in increase? I did, didn't I? That is terrible. There's terrible, horrible things that I did. And I did so many bad things. All right. So the change of wind speed based on the increase of air pressure. Okay. That's probably going to be our hardest part with a lot of these, is figuring this out. B's got to be harder. I mean, easier. What does the y-intercept of the function represent? Okay. Well, I said it's starting, right? Starting wind speed. Okay. Starting wind speed. Well, where do you think the air pressure is going to start? And it's hard to tell where it starts. So I'm just going to say the starting wind speed of a hurricane. Okay. It could be better, but that's probably good enough. Now, C, D, and E, that should be easy, right? How are we going to do C, D, and E? Are we just going to use this formula right here? On all three of them? And I'm betting that we're going to substitute for C, we're going to substitute 968 for X. I bet you on D, we're going to substitute 876 for X. And E, we're going to sub 63 in for what? For Y. Go ahead and do that and let's check it. Make sure you do put that negative in there. Okay, it looks like for C, I get I'm supposed to round to what? The nearest knot, which knot stands for nautical mile, in case you wanted. So I think I get 70, I have to round up, so I get 75 knots. Okay. So essentially, 75 knots, I'm not going to do the conversion, but that's pretty strong winds, right? 75 miles an hour. That's just like an average Saturday in Oklahoma, pretty much, right? Okay. That definitely is about what the wind felt like, a couple days ago during the softball game against Southmore, right? Which we beat. Okay. So probably D is going to be the same thing, but just I'm going to use 876 kilopascals. And again, if you didn't know that that's what that was, that's okay. Because we're not really worried about the science of it. We're worried about using our statistics to predict what that would be. And believe it or not, they actually build buildings based on what they think the maximum wind speed is going to be. And so there's different tests. And the study of the relations of air pressure and wind speed, in Oklahoma it's not hurricanes. What do we get when we have a problem with pressure? In Oklahoma usually. We get tornadoes, yeah. Old people can kind of feel that pressure change. It makes our knees hurt and our ears pop and stuff like that. So you can kind of feel when it's tornado weather based on the change in pressure. All right. What do we got going on here? What do we get? I'm not going to do the math. Is it going to be faster or slower? Someone's got to give me a number. What is it? Starts with a 1. What's the next number? Well, it sounded like that if I can't get the next number, we're just going to have to take this whole packet home and do it. And since this is going to take you a really long time to do it at home, I'll have to make it a lot of points. So what's the number? One what? There we go. 174 knots. Now we got one more thing to do. Let's get this done quickly. This one says the model indicates that the wind speed of 63 knots is associated with what air pressure? Okay, and so we're going to round. So we do 63. This one is going to require some work. Okay, and I'm not going to delay the video this much. So do your work. And I'll put the answer on the video, but do the work like before.